Okay, good morning. Welcome to
FamilyMath372.
FamilyMath372. So today we're going to talk about another question from James Tanton. This one's about triangles. He asks, is there a triangle with integer sides whose area doubles if you increase each side length by 1? Does this remind you of any question that we've done, say, recently?
That was the rectangle.
Okay.
One.
And what did we learn in the rectangle question?
Well, there was only one rectangle that did this.
And do you remember what it was?
It was 2 by 3 and 3 by 4. It turned into the 3 by 4.
Oh, I see. Okay, yeah. The 2 by 3 had an area of 6, the 3 by 4 had an area of 12, and that was it.
Yep.
So up to rotating that rectangle, there was only one way to do it. So now the question, which seems very similar. Is there a way to do it with a triangle? So before we dive in and before we get the marker there, give me some thoughts that you have about how you might approach this question.
Well, I would start first with a 2 by 3 right triangle.
A 2 by 3 right triangle, okay.
Or maybe a triangle with base 2. Just a triangle with base 2 and height 3.
Yeah, but we need to get all three sides. All three sides need to be...
Yeah, well, they don't all have to be integers, do they?
Yeah, is there a triangle with integer sides whose area doubles if you increase each side length by 1? Now, that's an interesting point that you make. I believe, how I interpreted the question is all sides have to be integers, not just one side has to be integers.
Then the right triangle 2 by 3 doesn't really work.
How come?
Because you have 2, bad marker. Well, you have 2 by 3. Huh. What's happening to the markers?
I don't know. I wrote with one of them. Okay. All right. We'll find it. We'll find a working one before we do the next slide.
So,
okay. 2 by 3.
4 plus 9 is 13.
So the old 2, 3 square root of 13 right triangle.
Yeah.
And just mark the little right angle there.
It's not an integer.
The square root of 13 is not an integer. Yeah, so that presents a problem. Like, maybe this one would have worked, except when you increase this side length by 1, it becomes 3. This one becomes 4. Does the new side become square root of 13 plus 1?
Well, that doesn't really work because the square root of 13 plus 1 is not 5.
Yeah.
Well, also, do the two triangles have to be similar to each other?
It doesn't say that. It just says the area has to double.
Well, because I'm pretty sure we could do... So, our right 3, 4, 5 triangle...
Uh-huh.
And then we could do a 2, 3, 4 triangle.
2, 3, 4. Okay.
Well, I see something that might help us here.
Okay.
So, the one with the boxes, or the rectangles, we wanted to see if, to go from the smaller rectangle to the next rectangle, we wanted 2 sides to stay the same and 1 side to double.
Okay.
So, building off of the 3, 4, 5 triangle, I think we could use that as the smaller triangle, and then do a 4, 5, 6 triangle.
Ah.
So 4, 5.
Oh, that, you know what? That's actually a really good idea.
6. So 4 and 5 stay the same, and then 3 to 6. And we don't necessarily have to find it to make it work.
Ah.
We know this is a valid triangle.
We know that's a valid triangle, but we don't know the area. We do know the area of this is 3, 4, 5. What is it?
It's 6. The 3, 4, 5 right triangle?
Yeah.
The area of... It's 3 times 4 over 2.
Which is
6.
6. That's interesting. So the area of the 3, 4, 5 is 6. 3, 4, 5, 6.
So 4, 5, 6. So let me draw that.
So we're hoping the area of the 4, 5, 6 is 12, right? Why don't we go to the next video and we'll try to find a good marker.
Okay.